This is Bob Capetta of the College of the Florida Keys, and this is Calc 1 Test 2 review on differentials. So here we're going to look at y equals 1/2 x cubed. And the first question I'm going to ask is to find dy dx when x equals 2. That requires us to take the derivative with respect to x of both sides. The derivative with respect to x of y equals the derivative with respect to x of 1/2 x cubed. So I get dy dx is 1/2 times 3x squared, or dy dx is 3/2 x squared. The next thing I'm asked is if x equals 2, and change in x equals 0.1, approximate change in y. Well, the thing to remember is that dy dx is equal to f prime of x. So for suitably small values, change in y over change in x is approximately f prime of x. So in our case, the change in y is going to be approximately f prime of x change in x, where x is 2 and change in x is 0.1. So f prime of 2, that's the value we're given here, times the change in x times 0.1. So f prime of 2, our f prime, if you will, is the same thing as our dy dx. Our derivative function, that's 3/2 2 squared. So change in y is approximately 3/2 times 2 squared times 0.1. So the change in y is approximately 412.6 times 0.1 is 0.6. So my change in y is approximately 0.6. Now, what's the actual change in y? Well, if we look at our function, let's call it f of x for the sake of discussion, is 1/2 x cubed. We could look at f of 2.1 and f of 2. F of 2.1 equals what? F of 2 equals what? And then the change in y would be the difference. So 1/2 of 2.1 cubed gives me 4.6305. And 1/2 of 2 cubed, 2 cubed is 8. 8 divided by 2 is 4. So the change in y is actually the difference of these two things. The change in y is actually 0.6305, pretty close to my predicted value of 0.6. So there's one discussion on a differential. Let's go ahead and do one more. Take a look at the square root of 6.16.2. So I will say use differentials. To approximate the square root of 16.2. So I need my original x would be 16. My change in x is 0.2. My original y is the square root of 16, which is 4. Goal, find change in y. Also, the f of x I'm dealing with is the square root of x, which is the same as x to the 1/2 power. So I think I have everything that I need to get started here. So f prime of x is 1/2 x to the negative 1/2, which is 1 over 2x to the 1/2, which is 1 over 2 root x. dy dx equals f prime of x. So change in y over change in x is approximately f prime of x. So change in y is approximately f prime of x times change in x. All right, I need f prime of my original x, which was 16. So what is f prime of 16? 1 over 2 root 16. 1 over 2 times 4, which is 1/8. So looking at my formula down here, the change in y is going to be approximately f prime of my 16, 1/8, times my change in x, which we said was what? 0.2 is what it should be. Change in x is 0.2, from 16 to 16.2. So that my change in y equals approximately 0.2 divided by 8, which gives us 0.025. So what's my prediction is that square root of 16.2 is approximately original y plus change in y. The original y was what? Original y was 4, plus the change in y we said is approximately 0.025. So we believe it's pretty close to 4.025. What is it actually? Let's just do a compare. The actual number, square root of 16.2 actually equals 4.0249, 22, etc. So my 4.025 is a pretty good approximation for that. Okay, let's do one more. I want to go ahead and use a differential to approximate the tangent of pi over 4 plus 0.03. So same idea. Use a differential to approximate tangent pi over 4 plus 0.03. I want my original x, my original y, my change in x, and look for my change in y. Original x is pi over 4. Change in x is 0.03. Original y is the tangent of pi over 4, which is 1. Find the change in y, approximately. My function that I'm dealing with here, f of x, is tangent x. So our concept is that dy dx equals f prime of x. So change in y over change in x is approximately equal to f prime of x. So change in y is approximately equal to f prime of x times change in x. And that's what we'll want. Our x of interest here is going to be pi over 4. So our change in y will be approximately f prime of pi over 4 times the change in x, which is 0.03. Now, what is my function? My function f of x equals tangent x. So the derivative f prime of x, derivative of tangent x, is secant squared x. So I need f prime of pi over 4. F prime of pi over 4 is secant squared of pi over 4, which is 1 over cosine squared of pi over 4, which is 1 over root 2 squared, 1 over a half, which equals 2. So looking at this, my change in y is approximately f prime of pi over 4, which was 2, times 0.03, which is 0.06. Change in y should be approximately 0.06. So I predict that my new value, my predicted y value, should be the old y plus the change in y. So my predicted y value should be the old y, which was 1, plus the change in y, 0.06, or about 1.06. Now, is that close to the actual number? So making sure you're in radian mode, the actual number for the tangent of pi over 4 plus 0.03 will be tangent pi over 4 plus 0.03 gives us 1.06187. So you see our predicted answer of 1.06 is pretty good. And that will end this lesson.